Welcome to the explainer. From the Wi-Fi that's probably connecting your device right now to the light coming from this screen, our entire modern world runs on this invisible force. Well, today we're going to decode that force. We're talking about the electromagnetic wave.
So let's just jump right in with a question. What's the connection between the light you see with your eyes, the Wi-Fi that's bringing you this explainer, and the X-rays a doctor might use to look at your bones? They seem totally different, right? Well, the answer, believe it or not, comes from a 19th century physics puzzle that made the universe feel, well, kind of broken. And our story starts right there. All right, so part one. Our story begins with what looked like a serious imbalance in the fundamental laws of nature, a kind of lopsidedness in how everything worked. Back in the 19th century, physicists knew this one simple fact. If you run an electric current through a wire, a magnetic field pops into existence around it. Simple enough. But here's the weird part. The reverse didn't seem to work. If you took a stationary magnet and put it next to a wire, you got nothing. No electric field, no current, zip. It just didn't make sense. The universe felt weirdly asymmetrical, lopsided. Then, the absolute genius Michael Faraday figures out a critical piece of the puzzle. He discovered that it wasn't the magnet itself, but a changing magnetic field that creates electricity. So, if you move the magnet, a current suddenly appears in the wire. But if you hold it still, nothing happens. The secret ingredient was motion. It was change. This definitely helped restore some balance, but it still wasn't the whole story. And this discovery got another physicist, the great Clerk Maxwell, thinking. He asked the next perfectly logical question. Okay, if a changing magnetic field can create an electric one, could a changing electric field create a magnetic one? I mean, that would be the final piece, right? The thing that would make the universe perfectly symmetric. And answering that question brings us to Maxwell's brilliant solution, what was truly the missing link in the laws of physics. So Maxwell came up with this fantastic thought experiment. It involves something called a capacitor, basically just two metal plates separated by an empty gap. So step one, you turn the circuit on. A current flows through the wires, and charge starts to build up on the plates. As that happens, a growing, changing electric field appears in the empty gap between them. But here's where it gets weird. This is the mystery. A magnetic field also appears in that empty space. But how? There's no wire in the gap. There are no moving charges. So where on earth was this magnetic field coming from? Maxwell's solution was just beautiful. He proposed a whole new kind of current. He called it a displacement current. He basically argued that the changing electric field in the gap was the current. Not a flow of physical stuff, not charges, but a current made of the field itself. And that was what was creating the magnetic field. It was the missing link. And just like that, boom, the puzzle was solved. A changing electric field absolutely does create a magnetic field. The universe was no longer lopsided. Its laws were suddenly, perfectly, elegantly symmetric. Now, balancing an equation is one thing. But what Maxwell didn't realize at first was that this discovery predicted something totally new, and frankly, extraordinary. A new kind of self-sustaining wave. See, Maxwell realized that these two fields could now feed each other in an endless loop. Just picture this. A changing electric field creates a changing magnetic field. Okay, but that new changing magnetic field then creates a new changing electric field, just a little bit further out in space, which creates another magnetic field, and so on and so on. This chain reaction, this cosmic dance, would just ripple outwards through empty space forever, as a wave that sustains itself. And this new theoretical wave had some seriously strange properties. For one, it's a transverse wave, which just means if the wave is traveling forward, the fields are wiggling up and down, kind of like a ripple you'd make on a rope. But even weirder, it didn't need any medium to travel through. Unlike sound waves in air or waves in the ocean, this thing could travel through the total, complete vacuum of empty space. And then came the masterstroke. Maxwell sat down and used his brand new equations to calculate the speed of this theoretical wave. The number he got was just mind-boggling. 300 million meters per second. Now, you have to understand, at that exact time, other physicists had already measured the speed of light, and guess what? It was the exact same number. The conclusion was shocking, but it was inescapable. This theoretical wave wasn't theoretical at all. Light, the very thing that we see with, is an electromagnetic wave.
Once that bombshell dropped, the floodgates just flew open. Scientists realized almost immediately that the visible light our eyes can see, well, it was just one tiny sliver of a huge, invisible family of these waves. And this right here is that family, the electromagnetic spectrum. And what's so incredible is that every single wave you see here, radio waves, microwaves, infrared, X-rays, they are all the exact same thing as visible light. They're all that same cosmic dance between electricity and magnetism, just playing at a different tempo. The only thing that separates them is their wavelength.
And this spectrum reveals a really clear pattern of how we use them. The long, lazy, low-energy waves, like radio waves, they're perfect for carrying information across huge distances, which is why we use them for communication. But the short, fast, high-energy waves, like X-rays, they can actually pierce right through soft tissue, which makes them perfect for seeing inside the human body.
Which brings us all the way back to our original question. What do light, Wi-Fi, and X-rays have in common? Well, the answer is everything. They are all just different flavors, different frequencies of the exact same physical phenomenon, that self-propagating dance between electricity and magnetism. So think about that. What started as just a hunt for symmetry, for elegance and a couple of equations, ended up revealing a universal force that literally powers our entire technological world. It really makes you wonder, what other cosmic symphonies are just waiting to be discovered, hidden inside the next unsolved puzzle?